From the vast expanse of space, Mars hangs like a celestial ruby, a beacon of rust red against the inky backdrop. Its allure is undeniable, a siren song to humanity's innate desire to explore the unknown. The fourth rock from our sun, Mars has captivated our imaginations for centuries. Ancient civilizations tracked its movements, weaving tales of gods and monsters around its fiery glow. Today, we know Mars not as a mythical entity, but as a planet, a world with its own history, its own secrets waiting to be unveiled. Telescopes reveal a world of stark beauty, a tapestry of canyons, volcanoes, and polar ice caps. We see vast plains of red dust, sculpted by ancient winds, and towering mountains that pierce the thin Martian atmosphere. The rusty hue comes from iron oxide, essentially rust, a testament to a past where water flowed freely on the surface. This evidence of a wetter, potentially life-supporting past is what truly ignites our fascination. Could Mars have once harbored life? Could it one day harbor us? The questions linger, driving us to push the boundaries of technology and venture further into the cosmos. Mars beckons, not as a destination, but as a challenge, an invitation to extend humanity's reach beyond the confines of our home planet. It is a call we are driven to answer, a journey we are destined to undertake. Our quest to understand Mars began in earnest in the 1960s with the Mariner missions. These early missions were the first to venture close to the Red Planet, setting the stage for decades of exploration and discovery. These robotic pioneers sent back the first close-up images of the Martian surface, revealing a world more complex than previously imagined. The images showed a planet with a rich and varied landscape, sparking curiosity and further questions about its history and geology. Craters, volcanoes, and canyons spoke of a dynamic geological past. These features suggested that Mars had once been geologically active, with processes that shaped its surface over millions of years. The Viking missions in the 1970s took us a step further, landing on the surface and conducting the first experiments searching for signs of life. These missions were groundbreaking as they provided the first opportunity to study Martian soil directly. While the results were inconclusive, they provided invaluable data about Martian soil and atmosphere. The experiments conducted by the Viking landers helped scientists understand the chemical composition and physical properties of the Martian surface. Subsequent missions, like the Sojourner rover in 1997 and the Spirit and Opportunity rovers in the early 2000s, continued to build our understanding. These rovers were equipped with advanced scientific instruments, allowing them to conduct detailed analyses of the Martian terrain. These intrepid explorers traversed the Martian landscape, analyzing rocks, collecting data, and sending back breathtaking images. Their journeys across the surface provided a wealth of information about the planet's geological history and environmental conditions. Their findings confirmed the presence of water ice at the poles and provided further evidence of a warmer, wetter past. This discovery was crucial, as it suggested that Mars may have had conditions suitable for life in its ancient past. The Curiosity rover, which landed in 2012, made a groundbreaking discovery: organic molecules, the building blocks of life, preserved in ancient Martian rocks. This finding was a significant milestone in our quest to understand the potential for life on Mars. The discoveries of these missions have painted a clearer, yet more tantalizing picture of Mars. Each mission has added a piece to the puzzle, revealing a planet with a complex and intriguing history. We know that the planet was once a very different place, with conditions that could have supported life. The evidence suggests that Mars had liquid water on its surface and a thicker atmosphere, creating an environment that could have been hospitable to life. The question now is not whether life ever existed on Mars, but whether we can find definitive proof and, perhaps, whether we can create conditions for life to flourish there once again. As we continue to explore, the dream of one day colonizing Mars and making it a second home for humanity becomes ever more tangible. While the allure of Mars is undeniable, the reality of its environment is stark. It is a hostile world, unforgiving to life as we know it. The challenges of surviving on Mars are numerous and daunting. The atmosphere is thin, about 1% the density of Earth's, offering little protection from the sun's radiation or the frigid temperatures. This thin atmosphere means that any heat from the sun quickly dissipates, leaving the surface cold and barren. Average temperatures hover around -80 degrees Fahrenheit, plunging even lower during the Martian night. These extreme temperatures make it difficult for any form of life to survive without significant technological intervention. Then there's the dust. Fine, reddish dust covers the planet, whipped up by powerful winds into planet-encompassing dust storms that can last for months. These storms can reduce visibility to almost zero and make navigation and exploration extremely challenging. This dust poses a significant challenge, not only to visibility and exploration, but also to equipment and potentially human health. The fine particles can infiltrate machinery, causing malfunctions, and pose respiratory risks to humans. The low gravity, about 38% of Earth's, presents its own set of challenges. While it might make exploring the Martian terrain easier, prolonged exposure to low gravity can have detrimental effects on human physiology, including muscle atrophy and bone density loss. While it might make exploring the Martian terrain easier, prolonged exposure to low gravity can have detrimental effects on human physiology. Muscles and bones weaken over time, requiring rigorous exercise regimes and potential medical interventions to maintain health. The lack of a global magnetic field, like the one that protects Earth from harmful solar radiation, is another significant hurdle. Without this natural shield, the surface of Mars is bombarded with high levels of radiation. Without this shield, Martian colonists would be exposed to dangerous levels of radiation, increasing the risk of cancer and other health problems. Protective habitats and advanced shielding technologies will be essential to safeguard human health. Water, the elixir of life, is scarce on Mars, locked away as ice beneath the surface or in the polar ice caps. Extracting and utilizing this water will be crucial for any long-term human presence on the planet. These challenges paint a daunting picture, but they are not insurmountable. With determination, innovation, and advanced technology, we can overcome these obstacles. They are, instead, engineering problems to be solved, obstacles to be overcome as we strive to make Mars a habitable world for humans. The journey to Mars will be a testament to human ingenuity and resilience, paving the way for a new era of exploration and discovery. Section 4. Engineering life on Mars. Technological solutions for a new home. The challenges of living on Mars are formidable, but human ingenuity is rising to meet them. The red planet presents a unique set of obstacles that require innovative and groundbreaking solutions. Scientists and engineers are developing a range of innovative technologies to transform this hostile world into a second home for humanity. These efforts are not just about survival, but about creating a sustainable and thriving environment. One of the primary concerns is creating breathable air. Without a reliable source of oxygen, human life on Mars would be impossible. The thin Martian atmosphere is 95% carbon dioxide, toxic to humans. This makes the task of generating oxygen a critical priority. To address this, scientists are developing systems to extract oxygen from Martian resources. These technologies aim to convert the abundant carbon dioxide into breathable oxygen. The MOXIE experiment on the Perseverance rover has already demonstrated the feasibility of producing oxygen from the Martian atmosphere. This is a significant step forward in making Mars habitable. Another key challenge is dealing with the extreme temperatures and radiation. Mars experiences drastic temperature fluctuations and high levels of radiation that can be harmful to humans. One proposed solution is building habitats underground or within existing Martian caves, providing natural shielding from the harsh environment. These subterranean shelters could offer protection from both radiation and temperature extremes. These habitats could be constructed using 3D printing technology, utilizing Martian regolith, the loose rock and dust on the surface, as a building material. This approach not only makes use of local resources, but also reduces the need to transport building materials from Earth. Water, essential for life, can be extracted from the Martian ice caps or from underground reservoirs that are believed to exist. Access to water is crucial for drinking, growing food, and other life support systems. Advanced filtration and recycling systems would be crucial to conserve this precious resource. These systems would ensure that every drop of water is used efficiently and sustainably. To address the low gravity, scientists are researching artificial gravity systems and developing exercise regimes and other countermeasures to mitigate the negative effects on human physiology. Maintaining muscle and bone health in low gravity is essential for long-term habitation. These technological solutions, while still in development, offer a glimpse into a future where humans can not only survive, but thrive on Mars. The vision of a self-sustaining Martian colony is becoming increasingly tangible. It will be a testament to our ingenuity and our unwavering spirit of exploration. The journey to Mars is not just about reaching a new world, but about pushing the boundaries of what is possible for humanity. Section 5. Journey to the Red Planet. The challenge of interplanetary travel. The journey to Mars is as daunting as the destination itself. The Red Planet lies, on average, about 140 million miles from Earth, a distance that varies significantly depending on the planet's orbits. Current technology would require a journey of 6 to 8 months, a long and perilous voyage through the unforgiving void of space. Space agencies like NASA and private companies like SpaceX are developing spacecraft and propulsion systems capable of safely transporting humans to Mars and back. NASA's Space Launch System, or SLS, and Orion spacecraft are designed for deep space missions, with the ultimate goal of human exploration of Mars. SpaceX, led by Elon Musk, is developing its Starship system, a fully reusable spacecraft intended to transport both crew and cargo to Mars and other destinations in the solar system. These ambitious projects are pushing the boundaries of rocketry and spacecraft design, paving the way for a new era of space exploration. The journey itself will be physically and psychologically demanding. Astronauts will face prolonged exposure to microgravity, confinement in a small space, and the psychological challenges of isolation and confinement. To prepare for these challenges, astronauts undergo rigorous training, including simulations of spaceflight conditions, emergency procedures, and teamwork exercises. The journey to Mars will be a testament to human endurance and a giant leap for humankind.